503, number 15, these are the ones that were in section 12.4. Section 12.4 was called our sampling distribution. Okay, so it wasn't talking about all of the individuals, it was talking about out of a sample. So we had to do, on the first types of problems we had 3 equations. You had to find the original z-score for the independent amount. Then you had to find the standard deviation of the mean. Then you found the z-score for the average of the sample. And then you compared those 2 things to see which one was farther away from the mean. So that's what we're starting with on here on number 15. Now our situation says, everybody, we're down here at the bottom where they have like the gym equipment. It says Wendy has a flower shop where she makes a mean of 127 sales per day with a standard deviation of 21 sales. Compare the z-scores of a single day making 140 sales with a 20-day average of 135 sales. Which is farther from the mean? So we have our regular mean and standard deviation there. The single day was 140. So that's our individual amount. So if you remember, our formula for z-score takes our x value minus the mean and divides it by the standard deviation. So our x value was 140. Our mean was 127. And the standard deviation was 21. And then this is going to give us a z-score. You always get a decimal. Z-scores usually only have how many decimal places?
1.
1. So I get this big long decimal. I just hit it and cleared it off. Look at that. That was good. 13. Let me try it again. All right, I get this big long decimal here. So is the 1 going to change to 6?
No.
So it's going to be 0.6. Okay. So that's my z-score for the individual single day. Okay. Now I have to find my standard deviation of the mean. So to find the standard deviation of the mean, you take your regular standard deviation, which was 21, and you divide it by the square root of the number of items in the sample. And when they did their sample, they said it was a 20-day average. So your sample size had 20. Now, when we do our standard deviation of the mean, we usually have how many decimal places?
3.
3. So I've got 21 divided by the square root of 20. And I get my decimal.
I got 4.696.
Is that right? Let's say
Yes,
that.
ma'am.
All right. All right. Let me get them in here. All right. Okay, so those of you that just logged on, you need to get caught up. We're on page 503, number 15. We're reviewing for the quizzes that we have. Okay, so we found our original z-score for the single day number of sales of 140. we found our standard deviation of the mean, and now we got to find the z-score for the average sales that they had. Now the average number of sales they had for that 20-day period was 135. So I'll take 135 minus our mean, which was 127, and I divide it by my standard deviation of the mean, 4.696. And again, you're finding a standard deviation on this one decimal place. Okay, now remember, we're trying to find out the one that is farther away from the mean. So your mean is your starting point, or like your origin on a number line. So that's 0. So if I'm thinking about my mean being 0, which one of these is farther from 0? The single day sales or the average sales?
Average.
The average sales was farther. Okay, so the 20-day average is farther from me. Okay, so that's what we do. Okay, so these are like, I think like the first 2 questions, or the first, I think it's like maybe the first 2 on your quiz 42 are like this that we're doing right now, like number 15 and 16. So let's do another one of these. Number 16 says, Paul runs a fitness center where he has noticed that his customers spend a mean of 41 minutes in the gym with a standard deviation of 13 minutes. Compare the z-scores of a single person spending an average of 61 minutes with a 19-person sample spending an average of 37 minutes. Which value is farther from the mean? So we're going to do on this one the same thing that we did here. We've got our 3 different things. We do the single person's individual z-score first. And so that person was there for 61 minutes. So you have 61 minus the mean of 41 over the standard deviation, which wasn't the 19. What was that, 13? The standard deviation? 13 minutes? Yeah. Glad y'all are helping me today. Okay. So we're ready to work this out. When you're finding the z-score, you have how many decimal places?
3.
Z-score has 1. So 20 divided by 13. So the single person's average of 61 minutes has a z-score of 1.5. Now we do our standard deviation of the mean. The standard deviation of the mean takes our regular standard deviation of 13 and divides it by the square root of the sample size. Now the sample, they said, was a 19-person sample, so you're going to divide that by the square root of 19.
I got 2.98.
2.982. Because on those, we keep 3 decimal places. Okay? Now, to find my z-score of the average, the 19 sample group spent an average of 37 minutes. So I have 37 minus the 41 over this standard deviation we found here, 2.982. So we'll take 37 minus 41, so you're going to get a negative on this one, and divide that by the 2.982. You get your decimal. You have to keep 1 place behind the decimal point, so it's negative 1.3. Now, just because one's positive and one's negative, you still look at the actual numbers themselves. So you're not worried about the sign, you're worried about which number is farther from 0. Is 1.5 farther from 0 or 1.3 negative?
1.3 negative.
1.5 is. The single value of 61 minutes was farther. That's all you do on those, okay? You're figuring out which one's farther from the mean. So now the way I did these on the quiz, okay, is you'll have to do out this work on your own paper somewhere where you have to find your z-score, your standard deviation of the mean, and then the other z-score. You look at your two z-scores, figure out which one's farther from 0, and then it's got like the little drop-down box. So like the first one will say the single value of whatever, and then the second one will say the 20-day average or whatever. And you pick the one that's farther from 0, farther from the mean, okay? It's a little drop-down box for those. Now, 17 and 18 uses two of the same formulas. It's talking about using the central limit theorem. So it just uses these last two formulas. So that's what we're doing over here on 17 and 18. Okay. So on 17, it says, we got to flip the page to page 594. On 17, it says, calculate the requested probability using the central limit theorem. So Jason enjoys going to the pool at his college and has noticed that students usually spend an average of mean equal 21 minutes in the water with a standard deviation of 8 minutes. If he were to take a random sample of 20 students, determine the probability that they will spend an average of 24 minutes or less in the water. So we start with our standard deviation of the mean, and then we do the average thing. So our standard deviation that you had was how many minutes?
8.
So we're going to have 8 over, and then how many people was it? 20? A random
people?
sample of 20 students, yeah. So square root of 20. So we have 8 divided by square root of 20. If you round it correctly, you should have 1.789. All right. Now for our z-score part, it said okay, what's the probability that they'll spend an average of 24 minutes? So 24 is our x value. So you'll have 24 minus the mean, which was 21, over the standard deviation, 1.789. Now this part, you're finding a z. When you're finding a z, we only keep one place behind decimal. Make sure you round correctly. You get 1.7. Okay, now what makes these different from what we were doing over here, we're not comparing a single person with the average. We want to know the chances that when we pick somebody out of a group, they're going to meet this average. So when we're talking about the chances, you're doing the probability, you're actually going to use the z-score and look at the table. Okay, now you have to be careful on this because you got to make sure whether it's saying more than or above or less than or below. Remember, because your z-score is talking about the chances that it's below. So it says, determine the probability that they will spend an average of 24 minutes or less. Less is below, right? So I don't have to change this. I don't have to subtract it from 1 because it is doing below. So now we look at our table. Everybody know what page the table's on? You should have it memorized by now.
567.
567, okay? So on the table, page 567, you look at 1 on the left and 0.7 across the top and get 0.955. And when it's talking about these with the central limit theorem, it usually says as a percent. So we move the decimal. It's 95.5% that he will pick one of those 20 people that will spend 24 minutes or less in the pool. Okay. So it's 95.5%. So number 18 is similar. Number 18 says, Amanda is a nurse at a doctor's office, and she noticed that the average height for their 10-year-old boy patients is 55 inches with a standard deviation of 7 inches. If she were to take a random sample of 10 10-year-old boys, what is the probability that their average would be 53 inches or higher? So you have to pay attention to that higher when we get to that last step. So we start off first with our standard deviation of the mean. Our standard deviation was 7 inches, and then she said there were 10 10-year-old boys, so our sample size was 10. So you have 7 divided by square root of 10, and get your little decimal. So round up to 4. I have 2.2135. 5 makes so the 3 go up. And then now I do my z-score. It says 53 inches is the x value. So I have 53 minus the mean of 55 and divide that by the 2.214. Finding a z-score, only want one decimal place. Is that what y'all got? Yes or no?
Yes.
Yes.
Okay, so now when we do this, this is my z-score, so I go to my little handy dandy table. So I go to -0 on the left and 0.9 at the top, and I get 0.184. Now remember, the number you get from the table is below. It wanted to know that they were 53 inches or higher. So I have to take 1 minus the 0.184.
Point 16.
And then I go 2 places, so it's 81.6% that the boy's going to be 53 inches or taller. Okay. All right. Number 19. It says perform a hypothesis test on the following situation. Include the null and alternative hypotheses, the p-value, and the level of significance. Okay. What I'm most worried about is you knowing how to identify your 2 hypotheses. Okay. That you can tell me the null hypothesis, which is the starting point, your original one that we're assuming true, and your alternative hypothesis, which is the one that we're trying to prove. So remember, HO is your null hypothesis, H0, and H1 is your null hypothesis, your alternative, null alternative. So looking on here at number 19, it says Lucy's fruit stand brings in, on average, $252 of revenue weekly, while the other 14 fruit stands in her area generate an average of $280. Does this prove that Lucy's average is lower? Assume that the revenues are normally distributed with a standard deviation of $70. Now, we're not worried about working out the whole thing. We did those yesterday. What I want to know is, what is the main average? So not her average, but the main average she's looking at. The other fruit stands all average $280, right? Now, she wants to know if her average is lower, what mathematical symbol can I use to show something lower?
Less than.
So I have the mean is less than $280, okay? My main thing, so the main part that you have on the quiz over this is just being able to tell which one's the null, which one's the alternative, okay? That's all you got to do. It's multiple choice. You pick the ones that's got the right set. Okay, we're not worried about working out the other part. We learned how to do that yesterday. That was good enough. Okay, because that was an optional section. Number 20, Kevin has found his car's average gas mileage to be 31.2 miles per gallon. If he takes a sample of 10 random people who drive the same car he does and finds their average gas mileage to be 27.6 miles per gallon, does this prove that Kevin's car mileage is higher than the average? So you're not looking at his average for this. You always use the sample's average. So his null hypothesis is the mean is equal to, what was the sample's average?
27.6.
27.6 miles per gallon. And then it said his alternative hypothesis is he's trying to see if his average is higher than that. So we use greater than the 27.6. Okay. So when you're doing the probability hypotheses, this number is the same in all of them. You should notice that your null one is always the what? What sign?
Equal sign.
Equal sign. Your null hypothesis is always what the mean is equal to for the sample, okay? Then your alternative hypothesis, if it's talking about lower, then it's less than. If it's talking about higher, it's greater than. So that's all you got to know for that part on the quiz. Okay, it's going to give you a situation just like I read. It's going to give you like 4 choices of these. You pick the right choice, the one that has them correct. Okay, so if it has these signs backwards, is that right? No, your null hypothesis, the one with the little 0, should always have the equal sign. Okay, so that's stuff you need for quiz. Now, let's look at some of our other part of our review. So we'll go back to like page 502. Okay, on page 502, a little bit closer. There we go. On page 502, with the first part, section 12.1 talked about our basic statistics. Okay, so our basic statistics dealt with population, which is your entire group, sample, which is the part of the group, the variable, what is being looked at or what is being asked, and then the classification, what type of information are they getting? Are they getting qualitative, where it's something in categories? Are they getting quantitative numbers? Okay, and if you're doing quantitative where it can be numbers, you need to figure out whether it's discrete, something that's counted, or continuous, something that's measured. So we have all these things that we have here, and number 1 is an example of that. So now we're flipping back over to page 592 to the beginning of chapter 12 review. And it says, answer the question for each situation. Karen measured the heights of 11 out of the 41 teenagers in her youth group. So the population is what?
11.
No. Population is the entire group. So there was 41 teenagers. The sample are the ones that she actually measured, which is 11 of the teenagers. Okay. What was it that she measured?
Height.
Heights. So the variable she was looking at was their heights. And classification, okay, since it's talking about measuring something, I know I'm dealing with numbers, so that means it's quantitative. And since it was measuring, I know it is continuous. Okay, so it's quantitative and it's continuous. Okay, now for number 2, it's the same way. We don't need to do that one. Those were, y'all did pretty good with those. Number 3 and 4 dealt with our basic statistics, our measures of center. Remember our 3 M's, mean, median, and mode. And then our range, which is a measure of variation because it tells how far the data is spread out. So on number 3, it says a construction worker kept track of the number of cars that passed by the work site every day for a week. So he has the numbers of cars that pass by. Apparently, he wasn't really working too much if he's sitting there counting all the cars that go by. But that's okay. So our mode is the number that shows up the most, right? Do any of those numbers show up more than once?
Nope.
No. So then we say no mode. If each number just shows up one time, then there's no mode. Okay? Can you have more than one mode?
Yes, ma'am.
Yes. You can have one mode. You can have more than one mode. Okay, part B is the median. Median is the middle number. Now, when you try to find the median, you have to have the numbers in order from least to greatest. So my numbers that we have are listed there for you in the book. The smallest one is 650. And then the next one is 678. And then the next one is 781. And then what's next?
868.
868. What's after that?
872.
And then
977.
is that it?
And then 985.
Ooh, Lord. Okay. That one's sticking off over here. But anyway. So I've got 1, 2, 3, 4, 5, 6, 7, because there's 7 days in the week. Okay. So to find my median, it's the number exactly in the middle. So if I've got 7 numbers, the one exactly in the middle is going to be my 4th number. So it's going to be 868. That's the median. Now, how do we find the mean?
Add them all up and divide by the number.
We add them all up and divide by 7. So let's add them up. Now, usually with these, it tells us to what place to round to. It said to round answers to 3 decimal places if necessary. So 3 numbers behind the decimal point. So I have 830.143. Because on my calculator, I get this big long repeating decimal. Hint, when you divide by 7, you're always going to get a repeating decimal. Okay, you round it off. Now, how do we find the range?
You said
Yes. You do what? highest number minus lowest number. So 985 minus the 650. So
You
what
get 335.
Okay. So, pretty good with that? Okay. Look at number 4. Number 4 says a receptionist recorded the number of phone calls she received every hour while she was at work. And so you have her numbers listed there. Mode is the number that shows up the most. So are any of those numbers repeats? Are any of the numbers repeated?
Yes.
Which one?
Number 3.
3. So there were 3 different hours that she had 3 phone calls in that hour. But since you only have one mode, it is called unimodal. If it had 2 modes, you would call it bimodal. Okay, but it's unimodal. Median, middle number. She was at work, it looks like, for 8 hours. There's 8 numbers there. You put them in order from least to greatest. So the first one is 1. Then I have 3 times. Then I have a 4, a 5, a 6, and an 8. She had 1 busy hour. Okay? So if I'm trying to find the median, the middle on this one, there's an even number of data. So there's 2 numbers that split the difference in the middle. So what's halfway between 3 and 4? 3.5. So your median is 3.5. Okay. Mean, we add them all up and divide by 8. Range, you take high minus low, and you get 7. Work on finishing your mean. You agree with that?
Yes, ma'am.
All right. Now, our next thing was one of our favorites. Okay. So this is what I'm leaving you with for y'all to work on, finish filling it in. Okay, we did this before. First thing, these are my X values for the situation. Okay. I have to first find my mean. Remember, X with a bar over it is your mean. How do we find the mean? We just talked about that. You add these up and divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will add all those up and divide by 10.
Ms. Pelham, what is the number under 95?
You have 95, 63. Yeah, that's where that, there you go, 63. Okay. So you find that, remember your first column is taking your X's here minus that mean. And then this column is taking the answer from this one and squaring it. So that's all I want you to try to do is make sure that you have finished that. And then if you want to try to work on more of the other review, you can. But the big thing that you need to work on is the quizzes. Okay, so I'll let you finish copying the table down and then I'll talk a little bit more about like the true false stuff on the quizzes, the definitions, and I'll let you all go. Okay, you can fill it in later. I just want to make sure. Now you have those initial numbers in your book, so if you can't see it, but I mean, just remember what the column headings are. That's the main thing. Okay. Now, what I want to remind you of is for the quiz, there's actually two. Okay, everybody be happy. It's Friday. You have till Monday to get them done. There's actually two. So we have quiz 42 and quiz H. Okay. Now, these two problems here are similar to like one of the, you've got, I don't know, I can't remember if I shuffled the questions on there on y'all or not. But anyway, you have one question on quiz 42 like that's like this. Quiz 42, you got one question like this. Okay? Quiz 42, you got one question that's using the central limit theorem like we did on 17 and 18. So you have a problem like this on quiz 42 and you have a problem like this on quiz 42. Okay? Now, the rest of quiz 42 is true-false definitions. Okay? The rest of quiz 42 is true-false definitions. So for these true-false definitions, if you like have your book open to the section that the quiz is over, section 12.4, these words are in there. They're in the bold print in the reading. So you should be able to figure them out for the true-false questions. So if I say, what type of evidence is an isolated case that is cited to support a claim? Open your book page to section 12.4. Look at it. It's in there. What type of evidence is an isolated case that is cited to support a claim?
Anecdotal evidence.
Anecdotal evidence. Good. Okay. What type of distribution is a distribution of samples instead of individuals?
Sampling distribution.
Sampling distribution. The name tells you what it is. Okay. The central limit theorem describes the properties of what type of distributions? What did you just say? What section is it in? Sampling distributions. That's when it talked about central limit theorem. So that's what it's used for. That's what this says. These questions that we did 17 and 18. Okay. The standard deviation of averages is the standard deviation divided by the square root of the, what's that formula? What's on that bottom there?
N.
The N, the sample size. N stands for the sample size. Okay. The central limit theorem states that as the blank increases, the sampling distribution will become more and more normal. Words we just said. Sample size. As the sample size increases, then it's going to get closer and closer to normal. So the larger number of people you look at, the closer it's going to get to the mean. Okay. Sampling distribution is a distribution of samples instead of individuals. Yeah, we already talked about those. So that's quiz 42. You have one problem that's like these. You have one problem that's like these. And then it's the true false with the definitions. You've got them there in the book. Now, quiz H is over section 12.5. Quiz H has matching. And then it has 3 problems where you're just picking the correct set of null and alternative hypotheses. So this part, number 19 and 20, is what you're looking at for quiz H. Okay? 19 and 20 is what you're looking at for quiz H. So, for example, it gives you the situation and then you just pick. Here, I'll show you mine real quick. Ready? See, it's multiple choice. So it'll have 4 different sets of these for each question and you pick the right set. Remember, your null hypothesis should always have a what kind of sign?
Equal.
Equal. And then you just got to pay attention. If it talks about lower, it's got to be lower is less than. If it talks about higher, it's got to have a greater than for your alternative hypothesis. Now for the matching part, what is probability that is calculated from real life data called? It was one of our definitions in 12.5. So you're looking at the bold print words in section 12.5.
Is it p-value?
The p-value, good. Okay. Statistics used to make predictions or decisions based on data. I've talked about this one a lot of times. Inferential statistics are used to make predictions. Original assumption assumed to be true is your what hypothesis? What's your original one called? What's the name for the first one?
No.
Null hypothesis. Let's see. Statements always identified first is just an hypothesis. Remember scientific method? You always start with an hypothesis. Okay. Judges a presumed population mean based on the sample mean rather than on an interval. The problems that we did with this is called doing hypothesis test. That's right there in the reading. I read it to you yesterday. What's this competing hypothesis called that's not assumed to be true?
Is it alternative?
Alternative. So the one that's assumed to be true is your null hypothesis. The one that isn't assumed to be true is your alternative hypothesis. Okay? And that's the matching part. So that's the 2 quizzes. Quiz 42 is over section 12.4, and it says so at the top of the quiz. Quiz H is over section 12.5. It says so at the top of the quiz. Okay? The majority of the quizzes are either matching with the definitions on this one or true false with the definitions on this one. You don't have very many problems at all. So you should be able to handle these quizzes. They should be a little bit easier because there's not that much work you have to do. Okay? Now, you've got the 2 quizzes over the weekend. What else do you have? Fill in your table for number 5. Okay? We'll work on that next week and continue reviewing because we got to get ready for your what? Exam.
Is our test still open? The other one?
You what now?
The chapter 11 test? Is our chapter 11 test open?
Where I went over it in tutoring yesterday, it's open till like 4 or 6 today. I got to double check. But it's like at least, I know it's open till at least 4 o'clock this afternoon. Okay? So it was open till at least 4 o'clock this afternoon if you didn't go ahead and try to retake it. And if you did try to retake it, you got to let me go back in and recheck it because, you know, sometimes you all may round to the wrong place, and so I still give you partial credit even though you didn't follow directions because it said keep 3 decimal places and you put 1. You know, some of y'all don't pay attention to directions very well. So I have to go back and regrade and give partial credit on stuff like that. So don't just assume when you get done, oh, it says I got a 42. Well, you may have got a 42, but you may have got higher than that too because I have to go back and recheck where you rounded, whether some of you put an extra space sometimes in there in between things. I don't know. I don't know how y'all type stuff, but I can't put all the different ways that you could type stuff in wrong. So it's easier for me to just go back and check them all. So I always go back in and recheck them. So I've still got to do that for those who redid it yesterday. I kind of looked to see who took it last night, but I didn't do a whole lot with it. So but it is still open till at least 4 o'clock today. So if you haven't redone that, you've still got that you can do. Okay. And the 2 quizzes, I think I have where they're open starting at 2 o'clock. So, and they'll be open all weekend till Monday, like at Monday afternoon. Same thing, it's like 4 or 5 o'clock Monday. Okay. Any other questions? Does everybody individually know what they still need to do?
Yes, ma'am.
Okay. Please, please, please get it done. We're down to the wire. Okay, you've got a week and then you have your exam week. And then you're done. Okay, so don't forget what I've told you, which ones are like what? 15 and 16, there's a problem like that on quiz 42. 17 and 18, there's a problem like that on quiz 42. And then the rest is true, false. Quiz H, you have picking the correct set of hypotheses and then matching with the definitions. So hopefully these 2 quizzes will be easier, better grades to help bring up at the end too. So go take your stuff, have a good weekend, and I'll see you all on Tuesday.